So free fall, this is now looking at when objects are moving in the vertical direction, and free fall is a specific case for when an object is only under the influence of the Earth's gravity. So right now we're saying gravity is the only force that is affecting the object's movement, how it's falling. Right now we're not going to look at any air resistance. So gravity is just the only thing affecting it. And here on Earth, when gravity is affecting our object, it has a very specific acceleration. So this is the acceleration of gravity on Earth. It is negative 9.8 meters per second squared. So this means that the Earth's gravitational pull is going to affect the speed or the velocity of an object by negative 9.8 meters per second every single second. Where does this number come from? We will actually calculate in a later unit where this number comes from, but the Earth's gravitational pull is dependent on how big the Earth is, how far away you are from the center of the Earth's radius, things like that. But right now, just kind of black box, you don't really know why or where this number comes from, but it is a constant here on Earth. Okay? So that is something we're always going to know. We're always going to know that if an object is moving vertically, that the acceleration in the y direction is going to be negative 9.8 meters per second squared. So kind of looking at how this affects our equations of motion. So we still have the same three kinematic equations of motion here. So let's kind of label it out. We're just going to be a little bit more specific with our notation. So our first equation of Vy is equal to Vy original plus Ayt. Now we always know what that Ay is. It becomes just another thing that we know. Delta y instead of delta x, so delta y equals Vy naught t plus 1/2 Ayt squared. So the only thing I'm really changing is I'm using y's instead of x's, and I'm just being specific and adding some y notation. And then our last equation is going to be Vy squared is equal to Vy naught squared plus 2Ay delta y. And then when we go to actually do our calculations, we already know this variable. This variable of Ay is always going to be a negative 9.8 meters per second squared. Okay. Something to note is if an object is dropped. Dropped is a very special situation where the Vy naught is equal to 0. And it actually makes our calculations simpler in that this first term in all of our equations goes to 0. This is similar to in our horizontal motion. When an object starts at rest, we know that our initial velocity is 0. When an object is dropped, our initial y velocity is 0. So let's go ahead and take some look at some nuances of throwing objects upwards in this case. So I'm going to kind of diagram out what happens when we throw an object up in the air, kind of what's happening to its velocity as it's traveling. So let's say that at time 0 seconds, I'm going to throw a ball up. And I'm going to give it a very particular velocity. I am going to give it a velocity of, so this is my Vy naught. This is going to be positive 19.6 meters per second. Very specific velocity. So I throw it up at 19.6 meters per second. Gravity is acting on it. The Earth's pull is acting on it. It's always going to be downwards. So I am always going to have this y acceleration of negative 9.8 meters per second squared. And I'm being kind of consistent in my color notation so you don't get mixed up between velocities and accelerations. Okay? So that's at time is equal to 0 seconds. So let's say I want to look at what happens 1 second later. So 1 second later, throw the ball up. 1 second later, the ball is probably going to be about here, we'll say. So this is time is 1 second. Gravity is still negative 9.8. Like that has not changed. My Ay is still negative 9.8. The Earth is still there. The Earth is still pulling it down, still slowing it down actually. And remember, that negative 9.8 meters per second squared means that every second the velocity in that y direction is changing by negative 9.8. So it was 19.6. I'm going to change it by negative 9.8 which means that now my velocity is smaller. My velocity is now 9.8 meters per second. Okay. So it decreased it by negative 9.8. Okay, another second. Ball's here. This is time is 2 seconds now. Gravity is still negative 9.8. That hasn't changed. Gravity is going to change my velocity by negative 9.8 meters per second, which means I was at 9.8. So now, actually my velocity is 0 at this point. And this is actually, this is right here, this is the maximum height. It has no velocity at that tippy top point. Like momentarily, it is got a velocity of 0. It still has gravity acting on it, still has this AY, but momentarily my velocity is 0. So my maximum height, my Y velocity is 0. Momentary interruption, sorry. Okay, so let's look at time keeps ticking. And I can't really, like, if I throw this straight up, it would actually fall straight down. But I can't overlay this, so I'm just going to shift it over here. So here's still my time is equal to 2 seconds. Like I have where my Y velocity is still 0. I still have gravity acting on it. Okay, so this is still 2 seconds, so let's look at 3 seconds. So 3 seconds, my ball is going to be the fall back down. So here we go. This is 3 seconds. Remember, my Y velocity was 0 here. Gravity is going to change my Y velocity by negative 9.8 meters per second. So if it was 0 meters per second, now it's going to be, oops, I made that too big. My Y velocity is going to be negative 9.8 meters per second. It's going to start speeding up in that downward direction. Gravity's still negative 9.8. Another second later, let's say it's going to be here. So now we're at 4 seconds. Gravity's still negative 9.8. Hopefully you're seeing that trend. My speed, my velocity though, remember gravity increases it by negative 9.8 meters per second every single second. So it was negative 9.8, now it's going to be negative 19.6 meters per second. And I hope you can see the symmetry here, that when I go to the same height here, I have the exact same speed. My velocity is negative though, because I'm going downwards, but I have the exact same speed. It takes 2 seconds to go up. It takes 2 seconds to come down. So there's definitely some symmetry here. There's definitely some things to kind of keep in mind. At the maximum height of an object being thrown upwards, the velocity is 0. Acceleration is always negative 9.8 though, okay? So let's go ahead and try an example. This should be in your workbook. I think it's on the next page though, so you don't have to write this down or copy down this example. So it says, worker on a scaffold throws a ball straight up with a velocity, oh sorry, I kind of got erased there. A velocity of 11.2 meters per second. So right there, that is my Vy naught. It's something that I know. And it's thrown upwards. Okay, so right there, this I did a positive in particular because it's thrown up. If it was thrown down, I'd have to make that a negative. Okay, so it's thrown up. What is the maximum height the ball reaches? We're trying to find, oh, there's something else I know. I know always gravity. Gravity is negative 9.8 meters per second squared. What is the maximum height the ball reaches? So that's the first thing I'm trying to find. Max height, so delta y at max height. Okay, that's a key phrase there, maximum height. I know that at maximum height that the velocity is going to be 0. At max height, Vy is equal to 0. So let's kind of think back to our kinematic equations. Let me bring this up here. Actually, I'm just going to write them here. We know Vy is equal to Vy naught plus AYT. We know delta y is equal to Vy naught t plus 1/2 AYT squared, and we know Vy squared is equal to Vy naught squared to delta y. So these are our three equations that show us how objects will move if there's a constant acceleration. So kind of looking at what I know my initial velocity, I know my acceleration, I'm trying to find my delta y, and I know my Vy is equal to 0 at this particular point. So these are the three things I know. The one thing I'm trying to find out, so we're going to look at our equations. Which of those equations has those four things in it? And we should see that this last one right here, has Vy, I know it's 0. I know my initial y velocity, I know my y acceleration, so this is the one I'm going to use. So Vy squared is equal to Vy naught squared plus 2ay delta y. I know at the very top my y velocity is 0. I know my initial y velocity is 11.2 squared plus 2 ay is always negative 9.8. And we're trying to find our delta y. So this becomes a matter of algebra. Here's your unknown. You can kind of think of it as, I have to bring this over to the other side, so this would be like negative 11.2 squared is equal to 2 times negative 9.8 delta y. And you should be able to do some math on the calculator, calculate this out. So I would, if I were you, I would pause the video, I'd get out my calculator, I'd actually calculate it, and you should find that your delta y is 6.4 meters. And it does come out positive, which makes sense because it's going, golly, I can't write a plus sign. It's going upward, so we should expect there to be a positive 6.4 meters. Okay, the problem continues. It says, how long does it take to reach this height? So I'm going to move this over, just so I have some more space. How long does it take to reach this height? The things I know, the initial velocity from the get-go is still this positive 11.2 meters per second. I still know that my y acceleration is negative 9.8 meters per second. I still know that at this maximum height, the velocity is 0. And now I'm trying to find time. So I'm looking, okay, here are the three things I know. This is the one thing I'm trying to find. Look at my three equations. Which of these equations has those four things? And you should see that it's this top one. So Vy is equal to Vy naught plus AYT. My velocity at the top is 0. Initial velocity is 11.2 plus negative 9.8 t. We should be able to solve for t. T should come out to be, what did I get? 1.143. Wait, last part of this problem. It says, what is the ball's position at 3 seconds? Okay, so this changes things. I'm no longer like thinking about that max height, so I'm going to kind of erase this stuff. I still know that my initial velocity is 11.2. I still know that my y acceleration is negative 9.8, but now I'm looking at a very particular point in time. I'm looking at 3 seconds, and I'm trying to find what is the height. So again, I'm looking at my three equations. I know initial y, I know the y acceleration, I know the time. I'm looking for delta y. Thinking for which of these three equations has those four quantities. And it's this middle one right here. This delta y is equal to Vy naught t plus 1/2 AYT squared. And I'm plugging in what I know. Initial velocity is 11.2. Time is 3. AY is negative 9.8. Times 3 squared. Don't forget the square. That's a silly mistake. Don't do that. And then it just becomes a matter of multiplying and adding, right? So delta y comes out to be, and it kind of crunching this out, be careful, I get negative 10.5 meters. What does that mean, negative? Well, what that means is this guy's on a scaffold, right? So kind of think of like a building here. I don't know, I can't draw all these windows. And this guy is on a scaffold here, standing, and he throws the ball up, and the ball comes down. So now the ball's like here. The ball is a negative 10.5 meters below from where he threw it, okay? Okay, so hopefully that gives you a little bit of exposure to free fall.